This is number 72 from Chapter 8. It looks at balancing redox reactions, but mainly also trying to, identify what is being reduced and what is being oxidized. So if we look at part A, we have a reaction that's given to us. That looks like this. We have solid aluminum reacting with 3 silver ions to produce aluminum plus 3 in solution, as well as then silver in the solid state. And if we have these balanced by atoms, it would be 1 to 3, 1 for the aluminum and 3 for the silver. In identifying what's being reduced and what is being oxidized, really the first step is, assign oxidation numbers. So if we look at, for instance, the aluminum on the starting material side, that's in its natural state, solid and monatomic, is going to be 0. And we look at aluminum on the product side, it's going to be in that plus 3 oxidation state. For the silver starts in the plus 1 oxidation state and then ends up in the 0 oxidation state because it's getting to its natural state. So that assigning of oxidation numbers basically then helps us to do the second part, which is identify what is being reduced or oxidized. And that's just by looking at the elements themselves and considering the half reactions. So 1/2 reaction would be the aluminum going to aluminum plus 3. In order to do that, the aluminum would have to lose 3 electrons in order to get to the plus 3 state. As a result, this is an example of oxidation. Because the aluminum has lost electrons. If we go to the silver has a plus 1 charge on the starting material side, and it ends up being a 0 state or 0 oxidation number on the product. Our balancing above showed that we needed 3 silvers for the balanced chemical reaction, and each one of those silvers is basically gaining an electron in order to go from the plus 1 state to that 0 state. So this is why we actually need 3 silvers, is because we want to make sure that our electrons that are being produced by the oxidation are actually equal to the electrons required for the reduction, which is a gain of electrons. So we could say in our final answer that aluminum is being oxidized. We would also say that the silver is being reduced. And so there's this other counter language that if aluminum is being oxidized, right, since it is producing electrons, it is the reducing agent. It's the agent of reduction. It's what causes the reduction. Since it's oxidizing and losing electrons, those electrons are then being used in the reduction step, and so that's why it's known as the reducing agent. The silver is being reduced, and since it is accepting electrons, it is equal to the oxidizing agent. So this idea of agent, whether it be reducing agent or oxidizing agent, means that they are the agent of that process. So the agent of reduction is actually the species that is undergoing the oxidation. The agent of oxidation is actually the species undergoing the reduction. So don't get tripped up on that language. But basically, to determine what's being oxidized, being reduced, to determine those then agents, is to assign the oxidation numbers that we see at the very top of the screen here, and then putting together and looking at those half reactions. Part B looks at SO3, sulfite, reacting with H2O. That's a liquid going on to basically form sulfuric acid. So we do the same steps that we did before. We need to assign oxidation numbers to really depict what's being reduced and what is being, oxidized. If we look at the sulfite, oxygen has a -2 oxidation number, and since there are 3 of them there, it would have a total of -6. So that means the sulfur must be in a +6 oxidation state. If we look at the H2O, the hydrogens are +1. Since there are 2 of them there, we have that overall of a +2. And so the oxygen then is going to be -2 like we've done in the past. We go over to then looking at our molecule H2SO4 that's aqueous, and we start to look at the oxidation numbers that are inherent there. We end up with our oxygens being -2. We're having a total of -8 in that particular oxidation assignment. The hydrogens are +1 again, so they have a total of +2 for their combination. And so the sulfur in this particular case is going to have a +6 oxidation state as well. So if we look at this whole process, right, we actually come to a realization that in this particular case, nothing is undergoing a change in oxidation number. As a result, that means that this is not a redox reaction. As a result. So you have to assign all of these oxidation numbers to really determine whether something is being reduced or something is being oxidized. In this case, all of the oxidation numbers for the sulfur, the oxygen, and the hydrogen are not changing. And since nothing is undergoing that change in oxidation number, this is not a redox reaction. Just to do one more in that sequence, let's look at C. C has barium as a solid reacting with chlorine as a gas to produce barium chloride as a solid product. Again, our first step has to be the assignment of oxidation numbers. And so if we do that, the barium's in its natural state. It's in that 0 state for the oxidation number. Chlorine as well is naturally diatomic. It's in that 0 state. And then if we look at our product, the chlorines are going to be -1. They're the most electronegative. There's 2 of them there, so you have a total of -2 from the both chlorines. That means that our barium must be in the +2 oxidation state. So here now we have our ability to determine what is being reduced or oxidized. And we can use the half reactions to help us visualize that, meaning that in the case of the barium, going to barium +2, essentially, right? Granted, it's going to barium chloride at the very end, but it's actually, undergoing an oxidation to get to that +2 state, and so it would be losing 2 electrons. That is our oxidation. The chlorine, that's diatomic, is really going to chloride, that -1 charge, and there are 2 of them there. So that means that each chlorine must have accepted 2 electrons. Well, I should say that each chlorine accepted 1 electron, giving us a total of 2 required since there's 2 chlorines. And so that is our reduction, our gain of electrons. And then really the barium +2 and the chlorine -1 come together to produce that solid product that we see above. So the barium solid is being oxidized. So this is our answer. That means it is the reducing agent. The Cl2 is being reduced. That is our oxidation agent. So that is how we are starting to get into balancing of redox reactions. Not so much balancing, but really defining how to determine what is being oxidized, what is being reduced by assignment of oxidation numbers. Once you know what is being oxidized and what is being reduced, then you actually know the reducing agent and oxidation agent respectively.